Hi everyone! Welcome to day 3 of APCSA PD with PopViz. Today we'll be exploring classes and objects. You've probably heard that Java is an object-oriented programming language, right? Well, today we'll take the first step into that world. Before we jump in, did you have any questions on yesterday's assignment? So let's take a look at the last lab question. The task here is to complete the nested for loop to output a star tree that looks like this. Let's first analyze the tree. The first row has one star, and every row there is an additional star. And if 3 is passed in the printer method, it'll create a tree with 3 rows. And if 5 is passed in, it'll create a tree with 5 rows. To get a better idea of what's going on, let's draw a grid around the star tree. You see that the number of stars printed for each row is equivalent to the R value of that row. So when R is 1, there is 1 star in that row. When R is 2, there are 2 stars. When R is 3, there are 3 stars, and so on. So let's start off the inner loop. For integer C, as in column, equals 1 semicolon. Now let's think about the condition. So this is the difficult part. And to get a better idea of how the columns are going to work, let me draw out the columns. Now I see the pattern. We need to print the stars R times for each row. So we need to repeat the loop R times for each row, which means that C is less than or equal to R, and we'll increment by 1. Inside the for loop, we're going to print system.out.print. Note that it's not println, it's print, because we want the stars to be printed next to each other. Then after we're done with a row, we'll need to move down to the next line. So after the inner for loop, let's put in system.out.println this time. And this will move the cursor 1 line down. And it looks like we are finished. So let's take a look at the input values that we're going to be tested against. They are 1, 3, 5, 7, and 10. So you can imagine what the trees may look like. And let's run. All right, starting from the first line, we have 1, 3, 5, 7, and 10. That looks about right, so I'm going to submit and see what happens. Great, it worked. Now back to the slides. So here is today's topic. Class. A class is like a template or a blueprint for creating objects. This class here is called mainPlayer, and it is created in a file called mainplayer.java. This class creates a mainPlayer object for a game. Let's take a look at what consists a class. Well, first of all, note that the class name must match the file name. If they don't match, you'll get an error. And a class has instance variables, which are like the noun properties or attributes of the object. This mainPlayer object will have a name and number of lives left. Then there are constructors to construct the object. Then comes the getters and setter methods that will work with the instance variables. And we've got other methods for this class. So this mainPlayer can run or jump. Think of these as the verbs that the mainPlayer can perform. This is what makes a class. Well, the blueprint itself cannot create the object, so you need to create the object from another file. And so here it is. This is the mainPlayer runner file that has the main method. Note that when you compile and run a Java file, the first thing that Java looks for is the main method. The file that has the main method usually has runner in its name because it runs the program. And inside the main method, we can instantiate the objects like this. And your object is born. And this object can use the mainPlayer methods like run and jump. Let's look at each of the components in detail. Here are the instance variables, the noun attributes of the class. These instance variables are private. Here, private means that you cannot access the instance variables from another class. The instance variables are only accessible within the same class. So why do they have to be private? This is for security reasons. So let's say that in this game, we let the users create custom names for the main player. If we allow the user input to be directly assigned as the name, then there's no way we can prevent inputs like this. It could have been a cat sitting on a keyboard that created this long, horrible looking name. Imagine displaying this name on your screen. It's not going to look nice. Another example is if we set lives left public, then it becomes accessible from another class, and it may allow someone to set lives left to, let's say, 1 million. It'll be a lot of fun, but let's not allow that. So for lives left, we keep this private and maybe even get rid of the setter method to be extra secure. So we'll cover the setter method soon. So it's a good idea to keep your instance variables private and work with them using public, getter, and setter methods. The constructor. Constructor constructs the objects. You can have multiple constructors, and when you do, they are called the overloaded constructors. Empty constructor is created for you as default. You can put it there, or you can omit it. The second constructor, like the one below, takes two arguments, string and an integer, and assigns them to the instance variables. We'll learn more of how this works in the later slides. Getters and setters. They work with the instance variables. The instance variables can have setter and getter methods. Well, you don't have to have both. So setter methods assign values to the instance variables, and it can prevent bad data from being set. Like the setName method you see here. It has an if statement that only allows string equal to or less than 10 characters to be set as the main player's name. Smart. And getter methods simply return the value of the instance variables. And here is how you can create or instantiate objects from a class. On the left, you have the main player class in mainplayer.java file. On the right, you have the runner class in mainplayerRunner.java file. The runner class is where you will instantiate or create your objects. When we create the objects, we call the class constructors to build them. And this is how you instantiate an object. You first put the class name, the name of the object, and assign it a new object. You can also create objects with set values by passing in parameters like this. You can have multiple constructors, and Java will find the right constructor for you by looking at the parameter type and its order. If the order and the type doesn't match any of the constructors in that class, then you'll get an error. Now let's see how the class file and the runner file work together. The first object, P1, is instantiated with the empty constructor. The second object, P2, is instantiated with the second constructor that takes string and an integer argument. Now let's call the main player methods on these objects and see what happens. Question: what would be the output for running these lines of code? The output is 3. We called setLivesLeft 3 on object P1, and the getLivesLeft returned 3. Next. So P1, or Mario, opened a lucky box and got 2 extra lives. Let's update lives left. P1.setLivesLeft 5. What is the output? Yes, the output is 5. Next, let's get the name of P2. What is the output? Great, the output is Sonic. Object P2 already had the instance variable set when it was instantiated. Therefore, getName returns Sonic. So that's it for today. Tomorrow, we'll cover integer, double, and string class. Let me know if you have any questions, and I hope you have fun coding, and I'll see you tomorrow.